Hello everyone, Bhavna Gunwani this side. Today in this session I am going to talk about collections in Java. Collection is basically a framework that stores and manipulates a group of objects or the entities together. Also, collection reduces the efforts required to write the code by providing the data structures and typical algorithms to store the different objects or the strongly typed objects. It provides the high performance and high quality data structure because it has various interfaces and classes along with, just like ArrayList, vector, linked list, priority queues, hash set, tree sets and all. It supports the reusability of standard data structures and algorithm just like queues, priority queues and the vector list as well. In easier words, if you will understand, the Java collection framework includes three iterations. One is the interfaces, majorly 3 to 4 interfaces we have in the collection framework that gives the support to store the different objects or the types. Classes and algorithms. Algorithm is basically imbibed in different collections. We just need to understand their working iterations. In easier words, if you understand, collection is just like a piggy bank. We all had it during our childhood, we know that, and where we used to store our coins. So similarly, the piggy bank is called as collections and coins are nothing but objects. So similarly, if we have any entity in a real time, like a group of students, group of suppliers, group of courses, so we create a collection of students, we create a collection of suppliers and so on, in which we store different entities imbibed together. So basically, collection framework is categorized into three iterations: interfaces, classes, and algorithms. They provide an easy management of a group of objects comprising in the java.util package that contains very powerful collection framework. And this feature is actually defined in JDK 1.2 and in each version it is being improvised. It is a kind of ready-made architecture for interfaces and classes which are used for storing and manipulating the group of objects. That's what we say, that all collection framework contains different interfaces, classes and algorithms that allows the data to be manipulated depending upon the user requirement, like add the objects into the collection, update them, remove them, check them whether they exist in the collections or not, and so on as per the conventional iterations we want it. Plus, the conventional ways are there to access these objects were not providing the desired performance and flexibility without collections framework, that is making our life much easier. This is a complete tree you can understand, which is having a iterable interface, which is the parent interface of the collection framework itself. Collection itself is an interface which comprises of three nested interfaces: list, queues, and sets. List has further classes to be implemented depending upon different behaviors: ArrayList, LinkedList, vector, which is stack imbibed from the vector class itself. Priority queue and array queue are imbibed from the queue itself. Set, we have hash set and linked hash set, and sorted and tree sets. You can see that here all blue are the interfaces that needs to be implemented into the further classes to define their behaviors. I am going to tell you the most common collection framework interfaces and classes. Majorly, I'll be covering the interfaces, then I'll tell you what are the classes that you can imbibe them together to do the operations with your entities and the storing of different objects all together. So stay tuned to learn more about collections in Java. Thank you so much, everyone. Hello everyone, Bhavna Gunwani this side. Today in this session, I am going to talk about the need of iterable interface. Then I will tell you how to overcome that scenario with the help of iterable interface, and then we have an iterator method inside that helps in iterating over the elements of the collection. As I discussed in the hierarchy of the collection interface, iterable is the first interface that needs to be extended or implemented into the respective interfaces and classes. So let's get started. As I told you, we already had a generic list in the generic sessions we had created, which defines the general purpose functionality to iterate over the different kind of objects, whether it is an integer list or string list or an object of any particular entity like user, student and all. That's what I have an add and get method with the very bare minimum functionalities. As I discussed, the purpose is to understand how to create generic list in this. Now I'm going to use this generic list in my iterable interface. So let's say I'm going to instantiate this list that is going to store string values, calling an add method to store the values, value1, list.add, value2, list.add, value3. Post that, I want to iterate this list to display the values. So as we know that if we have any list, we can iterate with the help of loop. I'm trying to iterate this list with the help of for each. Although the value is of type string, you can define var or string. Choice is completely yours. So you can see that here I wanted to iterate over each item from the list. Here we got it know that we are getting the error here. Why we are getting the error here? Because it is saying can only iterate over an array of or an instance of iterable but not the iterable interface. Because list is of generic type and generic type cannot be iterated with the help of for each loop. I can easily say for each is not applicable for type generic list. Let me write your error message here. So your error says that exactly in easy words, for each is not applicable for type generic list. So what exactly we can do is we can solve this problem with one more way rather than implementing the iterable interface. Using a for each loop, iterating each item from the list but not from the list directly. Under this list we have items array. So I can go to my generic class. I can make this class items array as public so that I can access it from outside the class definition. And the moment I say dot items, you can see that you can access the array but not the generic list. And now you can just print it with the help of sysout. So this is exactly this for each loop solves our requirement to be iterating the generic list. But the moment we talk about more iterations to be implemented in a real time, let's say this items array is not accessible anyhow, and we have so many other operations to do with the list that directly that we don't want to access any particular data member of that particular generic list or generic class. So how we will get rid of that issue? That's what the iterable interface comes into the picture to solve this scenario. So the iterable interface in Java provides a standard way of iterating over the elements of a collection. Basically, iterable interface allows the collection as a root interface for the entire collection framework, which is termed as iterable interface, which makes it easier to write generic code or generic classes that can be extended and into the type list and can be iterated with the help of for each loop. I should say that when you are using iterable interface to iterate the elements, then you are actually giving a syntactical sugar to the for each loop. Also, all the classes of collection interface can be traversed easily as it implements the iterable interface. As I told you in the diagram, in the hierarchy, iterable is a root interface, so it it indirectly extended or implemented into the all classes and the interfaces. So that's the reason all collection subclasses can implement the iterable interface that will automatically become a part of the iterable interface. Elements can be read, removed, operations like contains, get index of, is empty, clear can be performed with them easily. Furthermost, we have collection API as a universal cursor that actually helps in iterating each element as an object, and whatever operations we have performed with this, like adding, removing, finding the index of, each can be used to iterate over the elements of the collection of type E for the collection or T, whichever you have referred it. These methods are easy to use and implement, actually depending upon, as I told you, we have list, we have array list, we have in the list interface we have an array list. In the case of map or set, we have a different iteration. Like in the case of set, you wanted to do certain operations like union, intersect, and so on. So depending upon the requirement, what exactly the operations that you wanted to perform. So let's understand how iterable helps in getting rid of the previous issue. So exactly, first of all, I'm going to implement iterable interface of generic type T, whichever type I'll pass from the main method. You can see that it's giving the error that type generic list is having an abstract method that must implement. So I can quick fix to add unimplemented methods. So there is an iterator method. Now, what is this iterator method exactly? Let's understand. Actually, iterator is iterable interface returns an iterator of type E for the collection that helps to iterate over the elements. That's what the iterator interface has, specific methods that needs to be iterate each object into the collection. So let's first understand what is this iterator interface, which will be returned from this iterable. Iterator is basically an interface which returns an object which used to iterate through a collection of elements one by one. As I told you, collection interface itself behaves like a cursor. As the name itself suggests, it is used to iterate over the elements and used to modify and iterate over the elements in the collection. So whatever classes that implementing the iterable interface by default, if you implement the iterator in between of that and returns the object, all the classes can use its behavior. So iterator interface provides two main methods, although there are three methods: HashNext, next, and remove. But most commonly used are HashNext and next. Basically, HashNext, it returns true if there are more elements in the collection, otherwise returns false. Next returns the next element in the collection. It means we can access the value or collection element with the help of this next. It throws an exception, no such element exception, if there is no exception found in the iterator and you are trying to access. That's what we always check first. If has next, then only iterate the next element. In case you wanted to remove the current element from the collection, you can use it. But majorly we use iterator to iterate the elements and not modify. That's what the two most common methods that we use is HashNext and next. So this is what task performed, multiple tasks performed to iterate one element, two element, three element until we have HashNext. Otherwise the iterator ends up. So that's what I told you about HashNext, next, and remove. They helps in iterating the each element. Let's try to understand with the help of practical. So here basically this iterator will return the object, but we need to implement it because this is a generic class, and generic class itself is basically a user defined class. If we are using any specific ArrayList class or something, iterator is already implemented in that, so you don't have to write down the iterator class by your own every time. So here I'm going to create a list iterator for my generic list type that implements the iterator interface of type generic T. whatever type you're gonna pass to your generic class, iterable will take and that pass that type here as well. It will ask us to implement the methods like hasNext and next, most two common methods. Post that, what I exactly need to do is I need to instantiate my generic class type here. In the case of list iterator, I'll be creating a constructor private generic list of type T accessing through index, initializing my generic list in the constructor list iterator, then I'm going to initialize my list. Now as the work iterates through, the hasNext will return true or false if we have value until index is less than the list.count. List.count, list is an instance of generic list where we have a count variable to count the number of elements we have, and tnext will actually return the element based upon that index. That's what we say, return list dot index of items and then do plus plus each time. So each time we are calling a next method, iterates the elements and index gets plus plus. And that's what we need to call this list iterator from the iterable method itself. So here you can see that we are saying return new list iterator. So actually list iterator is an anonymous inner class type that is waiting for the object of current class. That's what we are just passing, iterator of object this. This means current class. So here by mistake I just said enter. I just rectified the spelling. Once it is done, I can easily go to my main method and I can see that I can iterate the list because my generic list is having a method iterator that is calling a list iterator to iterate each element with the help of hasNext and next method and returns each time in the case of accessing the var. Basically, this is a syntactical, for each is a syntactical sugar over the top of the element. So I can just simply say as sysout item. If you just wanted to use the iterator itself manually, you can also use that. Choice is completely yours. For example, if I am going to say that list equals to list.iterator. So you are calling this iterator method that will return the iterator of type T that will return hasNext and next references, which I wanted to manipulate here. So I just named this as an iterator also because list we already have. I can check here while iterator dot hasNext, just come inside the loop and say sysout iterator dot next. So choice is yours. This for each is a syntactical sugar to use this syntax of checking that if it has a next value, then iterate the next value, otherwise not. So I'll be definitely using this syntax in upcoming iterations or the classes. Let's try to run and iterate each item. I'm just gonna comment it out this one also because I can easily remove that because that I have demonstrated you already, and I can just iterate the list items. So you can see that it says that I have 3 values. I iterate each time value 1, 2 and 3. I hope this scenario is clear to everyone how to actually implement the iterator, that is in returning an object to iterate through the loop to access the collection object. And these methods like built-in methods that we have overridden as of now, because this time this list iterator is the manual class that we have created, and that is implementing the generic list to be iterated. As I told you, if you are using ArrayList or LinkedList kind of classes, this iterator is imbibed in that. You can directly use them. I'll definitely show you the scenarios, how to use them in practical approach. Until next time, stay tuned. Thank you, everyone. Hello, everyone. Bhavna Gunvani this side. Today in this session, I'm going to talk about the collection interface itself. As per the hierarchy that we were discussing, iterable is a extreme parent interface that helps in iterating the objects or a list of objects into the collection. Then we have collection itself, a root interface just after the iterable, and it also a general interface that being declared initially and can be used further into different interfaces and classes onwards. Basically, if I talk about this collection interface, as I discussed, it's a root interface of the Java collection framework just after the iterable. Iterable does not store the elements actually, it just helps in iterating, but collection interface helps in doing the basic operations with the objects like adding, removing, clearing the elements into a collection, checking whether the collection is empty or not, how to make the collection empty, and check that whether all elements needs to be removed and how many elements needs to be kept, finding the index of or other elements. Kind of index of cannot use here because can be used in the case of list interface that helps in iterating over the index. So different iterations are there. Further, we have list, queue and set, which are the components that extends the collection interface that you can use with. So let's get started to understand how collection interface to be used in programming. Here I'm creating a collection of string of class type ArrayList because we cannot instantiate the interface. I think everyone knows it now. Collection dot add value 1, adding the another element, says value 2, collection dot add the third value. So here we have 3 items into my collection. Simply print your collection sys out collection interface, collection instance. So here 3 values are getting printed. Would like to tell you moreover operations. If you want to add multiple values to a collection, there is a collections into the java.util also. We can use add all method of it. First it takes in which collection you wanted to store. This second is the 3 dots and then elements. 3 dots depicts that you can have multiple values into this list. So here I'm going to add 3 more values, value 4, value 5 and value 6. Let's say after that if I print my collection, there would be 6 values in total. 3 I was already having and 3 more I added just now. Post that, I would like to tell you some more operations. If you wanted to check the size of collection, you can simply check the size of collection with collection.size. If you wanted to iterate one by one all the elements, as I told you, by default, all the array list and all the classes implements the iterable interface. That's what you can directly iterate through for each. Var item from the collection, and here I just wanted to print it across. Sys out item. So here the size of the collection is 6, and one by one I'm iterating all the 6 elements of the collection. Post that, if you wanted to remove the specific item from the collection, so you can see that collection.remove, removing the item value 1. Post that, if you wanted to print the collection, just simply try it. And after that, if in case you wanted to make your collection empty, so there is clear method that helps in removing all the items. Clear, and then you can just try printing it again. Collection. So you can see that here I deleted the first value 1, then 5 values were left, 5 items were left, and then I used the clear method. My collection is empty. If in case you wanted to check that your collection is empty or not, you can simply check with the help of is empty. So here you can just use sys out collection dot is empty. If your collection is empty, it will return true. If not, it will return false. You can also compare two collections, guys. That's really amazing concept. Let's understand. To compare two collections, I already have one collection here. I just wanted to create one more collection, say collection of type string, other collection equals to new array list. I just wanted to add elements to this collection from the previous collection. I don't want it to add manually. Collection itself. And then I just wanted to compare here. You can see that if I compare collection equals to other collection, just have a look, guys. Collection equals to other collection. Ideally, it should return true, but it will return false. Let me show you and explain it to you. So you can see that it's returning false. This one is for is empty or not. So I'm just going to not make my collection clear here for 2 minutes because I must have the values. So here you can see that this is my one memory allocation to the collection and this is the another. So when you use double equals compares the memory allocation. That's what they are returning false. So if you yet to check the collection comparison with the elements, what elements we have in the collection, I suggest you to go for collection dot equals to method other collection and just return, it will return true to you. Just have a look. So in short, double equals operator helps in comparing two collections or values even, but it compares the memory allocation. But equals compares the content or the elements that we have in the collections. So that's all. We discussed how to add all, iterate, remove, clear, is empty, and comparing the different collections all together as well. Until next time, stay tuned. Thank you. Hello everyone, Bhavna Gunwani this side. Today in this session, we are going to talk about list interface. As per the hierarchy I told you, this list interface is also extended from the collection interface. It is an ordered collection of elements that allows duplicate elements too. Ordered collection means the order in which you insert the elements, the same way it gets stored. Unlike other types called set, A list is basically used to store ordered collection of data, and it may allow the elements being inserted that contain a specific value. The list interface as is found in util package and inherits the collection interface. It is being used in the further implemented into the further several classes like ArrayList, LinkedList class, and vector class. As I told you, we are already using the ArrayList class. So basically, as per the requirement, we use vector, ArrayList, or LinkedList. Most appropriate and most commonly used is the ArrayList. So you might have figured out this already in the case of collection. It is a kind of dynamic array. That means it does not have a fixed size. Its size can be increased or decreased if the elements are added or removed. Moreover, we have other types also. For example, if we have linked list class is also being implementing the collection interface but extending the abstract sequential list as well, because it is a kind of linked list data structure, a linear data structure where the elements are stored as nodes that are not stored in a contiguous memory, so direct access to that element is not possible. We do have vector type that allows to store the value, but just like array list, vectors are also a kind of dynamic arrays, but it extends the abstract list and implements the list interface. But array list directly implements the list interface and being implemented. One difference is there, vector is synchronized. It means only one thread at a time can access the code of vector. For example, if addition is being performed by one thread, then other operations cannot be performed until the first one is over. So it is a kind of legacy classes which are a part of, reconstruction. So let's understand how does this array list actually works that we're gonna use in this iteration or this demo. ArrayList is the most common kind of class being implementing the list interface. It is a kind of resizable array, which we also call it as a dynamic array. It is similar to an array, but it dynamically increases or decreases the size as an elements are added and removed. Since the array list cannot be used for primitive data types like int or etc., you just need to define the wrapper class that you want an integer class, or you wanted to store the integer elements or the string elements or other types. So here you can see that how data is getting stored that you can access with the help of index. There are some common methods that you can use. The most common difference that you can identify between the array list and collection is collection does not allow to work onto the index. That's what you cannot add the element based upon the index. You cannot find out the element that has a last index of into the elements or the index of method itself. So list interface and implementation to work with the index. So does ArrayList provides you. So let's get started to understand with the help of a demo. So guys, here also I am using a kind of operations with the list of string, where I'm adding three elements, value 1, value 2, value 3, printing the list items, so here we have three items in the list. Post that, I wanted to tell you moreover operations. If you wanted to add an item into the list at a specific index, let's say at 0th index, and you wanted to store a value as an initial value because value 1 is already being added, try printing your list after that and see the difference. So you can see that at 0th index, initial value is being added and every index is being shifted one towards the right. Post that, if you wanted to add multiple values, you can take in help of collections. This class has add all. You wanted to add multiple items to the list. Post that, you can add values here like value 4, value 5, and value 6. I'm going to print out my list here, so you can see that altogether there would be 7 values. Value 1, 2, value 6, and this is the initial value. Post that, if you wanted to get the element based upon a specific index, just say list.get index 0 or whatever value you wanted to get. If you want to modify the item in list on the basis of index, just simply write list.set. I wanted to set the item or modify the item that is at the index 0, and I wanted to say that it's value 0 rather than initial value. And post that, you can try printing your list and see the difference. So you can see that initial value is being modified with value 0. If you wanted to remove specific item from the list, there are ways. First of all, you can simply say list.remove, and the basis of index it will return remove the element. So initial value, which is value 0, will be deleted from this specific operation. You can try printing and check. You can also remove the element on the basis of, rather than index, you can simply pass a value. I wanted to remove the element where value is 1, value 1. After that, I wanted to tell you that you can find out the element based upon the index of. So simply say sysout list.index of a particular element. Let's say I am going to find out value 2. So if we have value 2 multiple times, the first come value into the list will be returning that index. If you have value 2 multiple times and you wanted to say that last iteration availability of value 2 in the list, that index needs to be returned. I mean to get the index of the last appearance of the item in the list. So you can simply say that sysout and say list dot last index of value 2, but unfortunately I don't have value 2 being repeated. And if you wanted to retrieve the sublist from the original list, you can simply say sysout list.sublist. So sublist will take 2 parameters, the starting of the index from where you need to start iterating, and up to index 3 or 4. So it will return the elements from index 0 to index 2. Up to 3, I mean less than 3. So let's check what will be the output. So you can see that index 0 to index 2, which is 2, 3, and 4 will be the value. So that's it. How does it happen? Value based upon the values that you have into the list, you can do all of these operations with the help of the list interface, and ArrayList class being most commonly used class in the case of collection. Until next time, stay tuned. Thank you all. Hello everyone, Bhavna Gunvani this side. Today in this session, I'm going to talk about the comparable interface. As the word name suggests, it defines a way to compare an object with other object of the same type. I already discussed comparable interface in generics module. Do not forget to go and watch that particular series as well. So basically, when we say that we are comparing two objects of the same type, it actually helps in sorting the objects that have self-tendency to sort themselves. It is available in java.lang package rather than util package because it's a common comparable interface, but we yet to discuss with generics and collections because comparable is a kind of generic interface. This interface has compare to method that helps to compare the objects. Comparable is not capable of sorting the data of its own. That's what we actually use a compare to method, or we implement that into the particular class or entity which we wanted to use this interface, that helps in sorting the object, because this compare to is basically used to compare the current object with the another object of the same type. Depending upon that particular logic, we write it here. The compare to method returns the negative integer 0 or positive integer depending upon whether the current object is less than, equals to, or greater than with a specific object respectively. It also matters inside that object to which particular attribute you are giving priority for the sorting. For example, sort by name, sort by email, or something. So this is a syntax of compare to. We just need to take up the object of the current class and we need to compare it with the current object of the class, and will return the integer value respectively depending upon the comparisons or depending upon the attribute that we are going to write it up. So let's get understand with an example. So here I'm going to talk about the customer entity, class customer, that implements the comparable interface of customer type. Because you can see that when I keep my cursor on it, I'll show you this has a compare to method, as I was talking about, that needs to be implemented to define the behavior of this comparison, returning the integer value as I said. So I'm just going to quick fix this by adding the unimplemented method here. As of now, I'm returning 0 for 2 minutes. Here I'm going to add the name, customer constructor to initialize the name, I'm also going to overwrite the toString method that will return the customer name. So let's talk about this compare to method. What this compare to method will do will compare the multiple customers, and we need to decide on which particular attribute, on the basis of which particular attribute we wanted to compare. As of now, I only have name. So let me tell you what it will return with this compare to. Basically, I'm writing a logic here that is a common for this compare to. For example, if the current class object is less than the object we are passing O, the other object, then it will return -1 or negative value. If current object is greater than other object, then it will returns 1 or positive value. And if the current object and the other object both are equals, then it returns 0. So this is how it works. You don't need to write down if this dot name is less than this other dot name or something. You can simply use a compare to attribute. Name dot compare to other dot name. So this compare to will check the current class object name and the other name. If depending upon this logic, it will return positive, negative, or integer value. Let's check this now in the main method. How does this work? Here I'm going to initialize a list of customer. List interface is in util.package. I discussed customers, new array list. Going to add 3 customers, new customer, customer A, customer B, and customer C. Let me just write their names in any different order. So if I print this list without comparison, this will be the value of names in the list. Customer name C, A and B. So here I could see that something is happening here. C, A and B. Now I can just use collections dot sort customers. For example, if you don't have comparable interface and the compare to method itself, and you are calling a collection sort, it is clearly saying that the method sort in the list, the method sort in the list is guaranteed to be stable, will arrange the data in ascending order. It is a mutually comparable with compared to, so that needs to be implemented to compare two objects one by one. First will take C, will take other object, pass on to the customer entity, will take other object A and will compare with the same, and so on. So this uses the compare to methods to compare two objects of the same class, and it also returns in which particular scenario it might throw the exception also. So the method sort in the type collection is not applicable for this argument because you are not going to implement the comparable interface or using a compare to method itself. So that's what you need to uncomment it first and then just call this and then again use sysout. Here we go. Customer name A, customer name B and customer name C. So that's how the comparable interface needs to be implemented into the classes or entities, and then you can sort the data, you can reverse the data and so many other operations you can perform too. I hope this concept is much clear to you now. Until next time, stay tuned. Thank you. Hello everyone, Bhavna Gunwani this side. Today in this session I am going to talk about a comparator interface. Basically the comparator interface is over the top of comparable interface that is used to order the object at a specific class and which is also found in the util package. So Java comparator interface helps in sorting or ordering the data in a specific order. This interface has two methods. One is a compare method that takes up two objects to compare, and another is a equals method. The compare method compares two input argument. It returns a negative integer, 0 or positive integer to state whether the first argument is less than, equal to or greater than the second one. And the equals method returns an object as a parameter and show if the input object is equals to the comparator or not. So I'll talk about it practically. It also provides multiple sorting sequences that you can use all together in one iteration. As I told you, it is a top-up of comparable interface, because in the comparable interface you need to modify your own entity, but here we actually create a different class to make it comparator. That's how the differences also comes into the picture. Comparable affects the original class, but comparator does not affect the original class, because we create a specific different class to compare the objects. Here we have a compare to method to sort the elements, and here we have compare method to sort the elements. Compare to method takes one object by which the current object needs to be compared. But in the case of comparator, it takes up two objects that needs to be compared together. That's what I told you. Both are available in the lang package. We can sort the elements in the comparable type by collection.sort and just passing the list. But in the case of comparator, the sort methods wait for the two parameters. The first is a list and second is a comparator class in which we have implemented the logic. Let's talk about it practically. Here I already have a customer entity with the name. I would like to also take one more entity called email. I can actually add this to the constructor also. Help in iterating it in my toString method. Customer name is this and email is this. Here you can see that it's crashing my constructor call. I need to quick fix, waiting for the two parameters. This way, email ID would be, let's say, c@gmail.com, c@gmail.com, a@gmail.com, b@gmail.com. So that's fine. I think it's fine now. We have this. Now what I need to do is we need to create so here I wanted to compare by email. So I'm going to add a email comparator class that will implement the comparator interface in which the customer type is passed as in generic type. For the time being, I'm just gonna comment it out this compare to. This email comparator is actually having a compare method that is an abstract method. I need to implement it. A very basic logic. We have two objects to be compared here. So this will return the same logic as I put it here now. The current object is less than the other one, it will return -1. If it is greater than 1, if it is equals then 0. So you just simply needs to return, or you just simply needs to call the compare to method, the o1 dot get. So now I wanted to compare with email and I don't have email as a public type. I have it as in private type, so I need a specific getter and setter for the same. So I can simply create a getter, even though I don't need a setter if I'm not wrong. Just get email should be fine. So here I'll say that object first dot get email dot compare to object 2 dot get email. Okay, so it is saying that customer is implementing the comparable interface and it's actually clashing it because you are implementing the comparable interface and you had not implemented the compare to itself. So let's figure it out. So as I told you, we are just not needed this compare to method because we have a separate class to compare as an email comparator. So I can just easily remove this implementation of the comparable interface in the customer, giving a priority to this comparator. Now, rather than in the sort method, you can see that I'm getting error because I told you while using a comparator interface, the two parameters needs to be expected. The first is the list that needs to be compared with the objects. The another is a comparator class in which you are actually comparing the objects. That's it. Now let's check it up how it works. So you can see that on the basis of email, the things are sorted. Email is A, B and C. You can also check it accordingly. If you make the changes like a kind of, you make the changes like X, Y, X and Z, you can see that your values are sorted accordingly. So when your email is actually sorting, the corresponding name is also getting sorted. A, C and B. Priority is actually the email X, Y and Z. I hope the concept is pretty clear to everyone. How does the comparator interface is being used and how it needs to be compared with the comparable interface exactly in a real time. Until next time, stay tuned. Thank you. Hello everyone, Bhavna Gunwani this side. Today in this session I am going to talk about the queue interface. As I discussed in the collection hierarchy, iterable extends into the collection interface, and then that collection interface extends into the further nested interfaces like list, queue and set. Queue is one of the interface that again extends the collection interface in this hierarchy. Basically, if you will understand the queue pattern, it works in a principle of first in, first out, just like a queue in a bank, queue in a printer. When you give a print command, the commands are instructed in a particular sequence. The first command that we have given, that will be taken out first. That's in, first out principle. Also, this queue is basically an interface that needs to be used along with the subclasses, just like a priority queue and array DQ. Although we have so many classes, but these are the most common that I'm talking about, just like a priority queue or array DQ. So let's get understand. So as I discussed, the queue interface provides the functionality of the queue data structure. As I discussed, the queue data structure works in the principle of first in, first out. It also resides in the util package and extends the collection interface as I discussed. In order to use the functionality of queue, as I discussed, queue is an interface. So subclasses like priority queue and DQ, array DQ needs to be used or implement this queue to arrive the requirements. So different classes has different iteration. I just wanted to show you some. So this is the official documentation of interface, queue interface, where it says that basically there are the sub interfaces of the queue as well, blocking DQ, blocking queue, DQ and transfer queue, but we actually needs to implement it. So we have implementing classes here, abstract queue, array blocking queue, array DQ and other classes as well. Most common are the priority queue and the array DQ which being used, because priority queue is the class that, as the name suggests, the principle of priority of the elements comes first. That's a first in, first out for the queue, but at times the element needs to be processed in their terms of priority, so that's we can use this. Apart from that, we also have array DQ, which is the most common. Array DQ is a basically iteration that helps in iterating the element, but there is no priority beings to be given the order in which they are inserted. The same way they needs to be processed in the first in, first out principle. Most amazing fact I'm telling you guys, the moment we do the operations like in adding the elements into the queue, removing it or peeking it out, we have different methods. Just to insert the elements, either you can use add or offer, either you can use remove or poll, or either you can use for examine whether which element is ready to eliminate. We can use element and peak. Let's understand what's the difference exactly between them. You can see that if I am going to add an element in certain scenarios, not in all the implementing classes, there could be a restriction to add the elements into the queue. So if your queue is full and you're trying to add the element, the add method will throws an exception, but the offer method returns a specific value, or it may returns a null that you cannot add anything, or it may also returns a false. So remove is something, we have a remove and poll method to eliminate the element from the queue. If you are going to remove and you don't have any element in the queue, like your queue is empty, so remove will throws an exception, but poll will return false or none, that you don't have any element in it. While you are checking that which element is ready to eliminate, as I discussed, we have a peak method also to identify which element is ready to pop out or delete. So if you're using eliminate and if your queue is empty, it will throws an exception. But if you're using peak, that you wanted to take out the element, but you're wanted to check which element is ready to eliminate, but your queue is empty, so peak will also returns false or none, but does not throws an error. So that's how their differences comes into the picture. So let's understand with the help of an example. Here I'm going to create a queue of string elements implementing the DQ class, adding elements to the queue, queue.add, queue.add, and the third element. So post that, you can also use offer method. As I told you, if your queue will be full and you have a restriction, then this will actually have a problem. Add method will throw the error and offer will returns nothing, actually nothing will happen. So that's what as of now no error for this. I just wanted to sys out what elements we have in the queue. So here we have A, B, C and D, 4 elements in the queue. Post that, we wanted to see that which element is ready to delete or remove. So I can just simply check element ready to remove. You can use queue.peak, or you can use queue.eliminate element. Considering I don't have any element in the queue, okay? So if your queue is empty, peak returns none, but element throws an exception. So if I am also commenting out it and checking that which element is ready to peak, peak returns null, as I discussed. But if you are trying to check with element method, it will throw an exception because your queue is empty, no such element exception. Similarly, if you are going to remove the element exactly, sys out element removed is, you can either use queue.remove or you can use poll. So when you say that remove method, if your queue is empty, remove returns none, but poll throws an exception. Going to comment out my poll method. This way. So you can see that if I'm going to remove, first of all, remove returns, okay. So let me just check the documentation. Remove throws an exception as it's doing. But if I do the same with the help of poll, it simply says null because element does not exist. Okay, so I hope the concept is pretty clear to all of you now. I just wanted to uncomment all of these statements just for your ease now. So that's how queue works. So many other operations can be performed. Whatever most common operations you have in the collection interface, that you can easily do. I have told you in the collection interface what are the specific methods and operations that you can perform, but these are specific to the queue itself. Until next time, stay tuned. Thank you. Hello everyone, Bhavna Gunwani this side. Today in this session I'm going to talk about the set interface. Basically the set interface defines an unordered collection of unique elements. Yes, you heard it right guys. Unordered collection of unique elements. It means it does not guarantee the order in which you have inserted the elements the same way it will be iterated, but if there would be any duplicate values, it will ignore it or remove it or eliminate it before iterating it. It extends the collection interface as I discussed. So again, I'm telling you all the pre-imbibed features of collection interface you can use along with the specific operations that you can perform with the set interface. It has several classes to be implemented like HashSet, tree set, linked hash set, even though enum set also. So these classes needs to be implemented, and popular classes, every class defines its own behavior. I'm going to talk about quickly what are their differences and iterations. Hash set is basically the class that, as I told you, implements the set interface, uses the hash table for storage, which uses a hashing technique, reducing the time complexity that we can compare with big O notation. Storing the unique elements as it guarantees get sorted in the same order. That's not guaranteed here, but elimination of the duplicates will happen. We can store null values to this as well. If I talk about linked hash set, basically it maintains a linked list of entries in the set that's being implemented along with the hash table. It contains only unique elements like hash set. Also, I would like to tell you it also maintains the insertion order. Multiple operations can be performed at a one time. As linked hash set is non-synchronized, so multiple threads at a time can access the code itself. So that really helps in iteration for the real time. And the another that we have is a tree set. Tree set class implements the sorted set. As because of this feature, it's having a vital role to arrange the data in ascending or sorted manner. Because as I told you, it uses the tree iteration, so data is sorted in this way. So retrieval time is fast, so time complexity is better improvised here. So let's understand how does gets implemented in real time. Here I'm going to add a set of string values equals to new hash set dot add. Let's say I'm printing sky is blue. I'm considering this blue 2 times. Would like to print my set. So first of all, you will see that two behaviors of it. It will remove the duplicate and it is unordered set. There is no order. Ideally, it should be sky is blue, but saying sky blue is no order is maintaining the way it's being inserted. Along with it is removing the duplicacy. That's the behavior of first behavior of the set interface. Post that, if I would like to create a collection and I wanted to remove the duplicate from the collection, then you can take an help of set interface. So remove duplicates from a collection. So what exactly we can do? We can have a collection of string values, let's say. New array list. Here I'm going to add multiple elements to my collection using the collection class collections.addAll. A, B, C, and then C. I'm going to create a set of string type, another set equals to new hash set. Going to pass on my collection into this hash set. So as if I'm passing the collection into this hash set, collection has a duplicate values which will be removed by this set interface. So I just wanted to print this set. So you can see that any duplicates would be there that gets eliminated. A, B, C. There were 2 C's in the collection. Along with that, we do have set operations to be worked with. Let me help you out with. So we have following set operations like union, intersection, and difference. Considering I have 2 sets, set 1, where I wanted to store arrays as list A, B, and C. Another set which is set 2, having different values and most common 2. B, C, and D. B, C, and D. So in both, we have 2 common elements B and C. Post that, I wanted to say union. Union means each element from the both set needs to be taken once. There is a method set1.addAll, set2. So all the elements from set 2 will be added to the set 1. If any duplicates would be there, that will be deleted or removed. So you can see that the moment I print set 1, all elements, unique elements will be added to the set 1, A, B, C, D. Similarly, if you wanted to opt out the intersection, intersection is common in both the sets. Intersection. I'm going to comment it out for 2 minutes because if I apply set 1, then set 1 will be considering 3 values A, B, C, D, not A, B, C. That's what I'm going to comment it out. So to intersection, we have a retain all method passing a set 2. So retain all is having a behavior that only common elements from both the sets needs to be taken. Now if you wanted to print set 1, so you can see that in set 1 and set 2, the most common are B and C. That will be returned, which is here. And similarly, if you want to make a difference between 2 sets, then we have set 1 dot remove all set 2. Here we go with, you can see that the difference is A because B and C are differentiated, minus from set 1 to set B. set 1 to set A itself. So that's how the behaviors of set operation works together. Moreover, all the common implementations that we have in the collection interface, you can use them here as well. Until next time, stay tuned. Thank you. Hello everyone, Bhavna Gunvani this side. Today in this session, I am going to talk about hash table. Basically, purpose is not to explain the hash table here because it's a part of data structures. But let me tell you something about it. Hash table is a kind of an array of a list where the data is stored a kind of a bucket in the form of key and value pair, just like the dictionary. So why we are talking about hash table here? Because the next iteration is a map interface. So hash table stores the key value pair in a collection, and to implement it we use the map interface. You can see that the class hash table storing a key value pair, extending the dictionary class and the map interface as well, because it does not allow the data to be entered without any specific key or a unique key to be entered. It uses a hash table internally to store the iteration. Basically, the moment we talk about the hash table classes are synchronized. Whenever, let's say, we wanted to do the linear comparisons to find out the element from a particular list. For example, there are 1 lakh items in the collection, and the item that you are looking out for is the second last or very last element. The worst case complexity is big O n. But if you would try to implement the hash table, it will actually reduce it to big O1 because hash table does not compare each element. Just look out for the particular key of that particular value depending upon which you wanted to iterate with. So different technologies have a different implementation of hash table to be used with. For example, if you wanted to use a key value pair to be storing into the list, then you can go for a maps in the Java, hash maps. You can go for dictionary in C#, dictionary in Python, and objects in JavaScript, because in JavaScript we stores the value in key and value pair, like kind of. So let's understand how does this map interface further works. The map is a collection that stores the value in a key value iteration or a dictionary iteration where each key is associated with a value. Map is an object that stores key value kind of pair elements. It contains unique keys, as the same key cannot have multiple mappings. That's what we call it as a key. Although a part of the collection framework, maps are not themselves collection because they do not implement the collection interface. Please mind my words, right guys? That is the reason I didn't added the map interface in my hierarchical tree earlier, because it's a part of the collection framework, but maps are not themselves collection because they do not implement the collection interface. That's it. And HashMap basically extends the abstraction map, implements the map interface using the iteration to store the data. And we have so many other nesting interfaces in classes like sorted map and navigate. Map are interfaces that's implementing the map interface to define their behaviors depending upon their iterations. And then furthermost is a tree map. Let's understand with the help of an example. I am considering I already have a customer class that we have discussed in the case of comparator interface. I wanted to store these customers into the form of key value pair. So I'll just come up into my main method and initialize two customers C1. You can directly initialize while adding into the map, or you can just make it ready initially. Just here I'm say A and email is A1, and this is B1 and this is B. So I have two instances ready, C1 and C2. Going to create a key value pair using map. So my key would be the email ID, should be unique, and value would be the entire customer object. Okay. I would like to put the elements into my map. So first is a key. I would like to say c1.getEmail, and the second object is the c1 variable, reference variable of the customer entity. Then again map.put c2.getEmail, and then c2 is the reference. If you wanted to print it as it is without iterating, without modification, just print your map and see the key value pairs. So you can see that this is your first key value pair. A1 is a key and value is name and event. B1 is a key and the key respective value is in complete object. You can do one thing, guys. You can just put on the square brackets here. That will easily help you to identify the groups. So you can see that this is my first key and this is my second key. Okay. Let's take it up forward. Would like to tell you a couple of iterations here. If you want to retrieve the customer with key, then you simply need to say sysout map.get, in which you need to pass the key. For example, I want to find out by A1. So if A1 is there, it will return that A1 has a name A and email A1. If in case you pass on the key which does not exist, in that case, you will get none. For example, I want to retrieve with the key, but I want to say that if the key does not exist, then assigns the default. Declaring it here as an unknown instance of the customer entity. Name is unknown and email is also unknown. Post that I wanted to get a customer. I wanted to say map.get E1, although it exists. So if it exists, then returns the E1 value. If it does not exist, then returns the unknown object. So here, rather than get, we'll be using get or default, because we are setting an unknown instance as a default type. Let's understand. So E1 exist, E1 not exist, A1 exist. That's what it is saying, unknown. If you write A1, because it exists, it will just return the same object which is available. Name A, email A1. I hope the concept is clear to you. If you want to check if customer exists with a particular key or not, with the help of Boolean value, you can simply check map.exist or contains key. If A1 exists, it will return true. If not exist, it will return false. Okay. If you want to replace the customer with the key, you can simply say map.replace. Wherever the key is A1, that object needs to be replaced with the new customer entity. Let's say C and C1. Whatever name you can give it, guys. I just go with a chain. That's it, I think. Moreover, you can also print all the keys. You can use a for each where we need to use only key. Here we have map.keysets. So you will see that the moment I will be printing the keys only, sysout key. How does it print the keys? So I have two keys, A1 and B1. If you wanted to print the values, just go for the for each loop once again, where value map.values. sysout value each time. So you can see that the values are the customer objects. Post that, if you wanted to print entry sets, go for var entry map.entry sets. Just print each entry. Sysout and entry. Here we go with A1 is a key and name email is the value of it. B1 is the key and name email is the value of it. So this is exactly how the things comes into the picture in the case of map. As I discussed, you cannot use the collection methods because it does not implement the collection interface. It has a specific on behavior, part of the collection framework, but not implementing the collection interface. That's how it goes on. I hope the things are pretty clear to everyone. Until next time, stay tuned. Thank you.